Greetings, the Astro 30 here, and today's little kit build is this, which I received in the post last week. It's a miniature Christmas tree, a flashing Christmas tree. I know Christmas is over now, but it's a miniature flashing Christmas tree kit, which I thought was kind of cute. It was very inexpensive. It was only like $7 or $8 on eBay. So let's just open this up and have a look at what we've got here. So we've got a USB cable to a DC adapter, so it can run off of a USB adapter or the computer or whatever. We've got one side of the tree. It's a little bit more smaller than I thought, so that's one side. We've got another side, so these two would actually interjoin together, like something similar to that, and as long as all the positives and negatives line up the right way round, it will work fine. Got a bunch of LEDs, resistors, DC power jack, a couple of transistors, etc. This 4.5 volt battery tray that you put AA's in, so they give you 4.5 volts, and the baseboard. So this would be the way it goes up. But they didn't give you any standoffs to hold it up off the desk or whatever, or mount it in something. I've got some sitting here anyway, so that's no big issue. So I guess what we would start with is we would start with this board, and I'm actually thinking that you probably don't get standoffs because you'd be screwing this on instead. However, yeah, I'd still put in some standoffs there, 15mm ones or something, just to, you know, stop it like just resting on the batteries. So, okay, so the first board I would assemble would be the baseboard. I'd start with, oh, it's even got an on-off switch, how cute. So to start with that, the DC jack, but I won't actually put the battery connector in yet because, well, I'll need to get to the underside to solder it properly, these two other halves. So yeah, I'll start with that. This should be a relatively simple one to assemble, so let's get started. Okay, so I've got that DC socket soldered in. I soldered one pin just to get it to line up because it's got two little tabs that sit in through drilled out holes in the board. And now I've got this on-off button. And with my previous history with buttons, I just want to make sure that it doesn't really particularly matter which way round you solder this in for it to still work. There is no instructions with this kit, so I'm playing it by ear, and it's made by a company called EQ Kit, just for your information. But there's no actual instructions on how this switch should be wired, but I can see, if you look here, there's only two traces used. There's one here and one here, so that's where the switching action happens. So whichever way I measure with a multimeter on one of these sides that I actually get a switching action when it's in, like continuity on the meter, is the way I'm going to solder it in the board, so I know that when I push it in, these two are going to be connected. Nothing happens. Push the switch in. We have continuity that way and on the other side of the switch as well. So there's the continuous both ways. So I know that if I put the switch in the way it's sitting, like this, into my board and tack one of the ends in. I put it in the board this way as it was and just tack one of these pins in without it falling out, and it just fell out and I don't know where it went. On my penis. So I've just got to now reconfirm where that switch point is. Tack one lead to the board, and then I can solder the rest of them. Bridge that one, of course, and make it permanently on. I've got to fix that up with a solder sucker. This is why having your solder sucker on hand is handy, because you can... Oh, I just cleared it anyway, I didn't need the solder sucker. So that's soldered in. And now I'm just going to re-verify that that is switched on across these two pins, which it is, and then I'm turning it off, and there is nothing there now. There's nothing anywhere on the switch now actually, so yeah, it is critical which way around you put this switch, or else it's not going to work. Yeah, there's no continuity either there either. So yeah, it's only continuous when it's there. So you're going to have to measure it with a multimeter and just double check where the switching part is, because otherwise nothing's going to happen when you turn it on or off. So it doesn't hurt to actually check. So now that we've got those two components in, well, I guess I can put the battery compartment on, and they do provide you with some bolts and nuts for that. Now the only problem with this socket is that there's no wear on the outer casing for these wires to pass through. So, and I don't really want to pass them back up through the battery connector, so what I might do is I might take a pair of side cutters, and I don't think it's really overly critical where I'm going to cut it. I might cut it on the side that is going to exit away from the screw hole. So I'll just cut out a bit of the plastic there, like so, just so I can pass the wires through it. So that's sort of the idea I was going for, and then I can pass my wires through that gap, and it won't actually make the thing look cockeyed when it's actually screwed to the board. Now I did say I was going to leave this to last, but well, I reckon I can still solder the tree elements to the top side of the board, so I don't think it's really that big of a deal. So I'm just going to screw them down now. Okay, it's extremely hot here today and I'm sweating like a bloody pig, but you get that. So now I want to get the battery wires connected, but I don't obviously need all this length. So what I'm going to do is I'm going to cut them down to about there, and then I'll strip the wires, tin them, and they pass through these 2 points marked positive and negative. So the red goes to the positive, the black goes to the negative. Solder them into the board. There we go there. That's the battery connected up. Now I'm not sure if they've got any physical isolation. I reckon because there's a trace going up to here as well. So I'm not sure if they've got any isolation at the DC connector, so that it's like switched is what I mean. So when you plug the DC in, the positive and negative aren't connected to the rest of the circuit, so you're not trying to charge the battery. We've got nothing, no continuity whatsoever. We should have continuity to the negative, obviously. Well, we don't have continuity to the negative either. That's interesting. Okay, so I'll unplug the connector. It might help if I turn the power switch on too. Okay, so we've got continuity from the battery to the positive and continuity from the negative of the battery to the negative. Plug the connector in, the plug-in. Do we still have continuity from the positive of the battery? No, we don't. So it actually switches it out of circuit, so that's alright. So there's nothing worse than charging an alkaline battery and ooh, that's just ripped through. That screw has just ripped through the case there. Okay, I think I can fix that. Okay, so what I ended up doing was I took some of these, a couple of these actually, earthing tag eyelets, and I cut the eyelet end off because that was just small enough to fit the screw through, and I just used it as a sort of, well, bodgy washer, so to speak. It'll do the job. It's nice and tight now. It shouldn't interfere with the batteries too much, but just be mindful of that, not to over torque these nuts because it will rip through the plastic, obviously. Okay, so that's the bottom board complete. I'm going to move on to doing each tree board, and all the components are actually marked on the board. It doesn't tell you which order to put the LEDs in, what colours, etc., but I guess you just choose your own colour. There is a thing up here which I'm not sure whether that's for an LED. I reckon it is because the other board says positive negative, so you could actually put another LED up there as a star, I guess, but yeah, I'm not sure. But we've got R6, R4 which is not marked, R7 which is not marked, which is handy, so I don't know what these resistor values should be. That's 10k, that's 10k, R2 is not marked, R3 is 10k. So this is going to be kind of interesting. So I might actually have to go onto the eBay site and actually see if there's actually a set of instructions for it. Unfortunately, no, there's not, which is kind of handy. I mean, it'd be really handy if you know, like included some instructions in this so that we're not flying blind here as to, well, where do the 3 ohms go? Where do the 1Ks go? And yeah, this is frustrating. Thank God for the internet. I just actually looked online. I did actually find the same kit. There's on instructables.com, and it actually just shows you what all the parts are, which is handy. Now I know what R6, R4 and R2 are. I know where the 10Ks go because they were marked, but this was the confusion here. I didn't know what R2 was, or R6 for instance, which is on the first page. R6 is a 330 ohms, so I know now where to put the stupid resistors, so that's very handy. I'll put a link in the description to the Instructables article because it'll be very handy. So I've just gone and done the 10Ks first. Once I now know where the parts go, it's only the resistors I didn't know, makes it a lot easier to assemble. Just saying, all these sellers on eBay that have this kit for sale don't have a link to a PDF or even to the Instructables site. It would be very handy and in their best interest to do so, because I know it didn't take long to do a Google search, but yeah, I shouldn't have to. Okay, that's the resistors on the first board done. I've got to just do the same thing on the other. We've got some 10Ks left over. We've got like 2 of them, so I'll keep them for something else. So it's just a matter of looking at what parts are what. Okay, I've got all the resistors done on both boards. I found an extra space for another 10K, so I've got still 1 left with nowhere to put it. One board has 7 resistors on it. The other board only has 6, and I can't see anywhere else I can put another 10K, so I'm assuming that's all the resistors done. So now I'm going to move on to the capacitors, and with the electrolytics, in fact they're all electrolytics, you would be basically just laying it flat against the board, obviously the right way around. So that's exactly how I'm going to do it. and we'll come back when I've done that. I'll even put in the 2 transistors, well 3 transistors on this board and 3 transistors on that board. Okay, I was just looking at the parts list I printed out, and they say 47 microfarad 16 volt for C1, 2 and 3, C1 to 3, and yeah, C1 to 3, and I've got 6 47 microfarad 16 volt, and on the board it's marked 22 microfarad. So they've changed it. So I was just confused there for a while, but then I looked at it and thought, no, whatever the parts list says is what it is. So you can basically pretty much ignore this silk screen because, well, it doesn't print half the component values, and when it does, they're wrong anyway. So I'm not really overly impressed with this kit at the moment. So, but $7, I suppose you can't complain. So all I'm going to do is just do these capacitors, as I said, lay them over and just make sure you get them the correct polarity. There's a little square pad where the positive goes, and just double check that you've got it the right way around before you solder it. Notice one other thing, the Chinese like to use S9014s and S9016s, I think they are, quite a lot. I suppose because they're cheap Chinese transistors, aren't they? But I've noticed a lot of Chinese kits use the same S9014 transistor. Okay, that's both boards populated with the capacitors and the 3 S9014s. Now, would I recommend this kit as a beginner's kit? Well, yeah, if they would fix the overlay and actually include what the component values are supposed to be and the correct ones, it would be nice, or at least have a PDF file if you're going to change stuff to update us. So now all I need to do is do the LEDs, and I might go have another look at the Instructable site. So they say from D1 through to D6, wherever they are, is to install red LEDs there. So that's what I'm going to do, and they sort of like bend over at right angles to the board, so I can just see where the cathode's supposed to be. That's supposed to be around that way. So we're going to be putting them in like that and bending it off over the edge like that. So that's going to be from D1. I can see D3, so D3. D2. And that'd be on both boards. I can see D5 over here. I've got D3, I need D6. I can see D4 as well, so D4. And D6. So we do that on both boards and then solder them in. I think it's just as easy to solder them from the top. I mean, they're plated through holes, so it doesn't really particularly matter where you solder them. It just happens that this is facing up, and it'll keep my LEDs looking in a nice alignment anyway. I mean, I can always go on to the back of the board and touch it up with some more solder after I clip them off if I'm not happy with the joints. And you can choose which way around to put your LEDs. I'm just going by what the Instructables document says, and that's the way I'm going to do it. So it's exactly matches up with their documentation. So next we install yellow LEDs on D7 to D12. And of course the remaining LEDs D13 to D18. I think, yeah, D13 to D18 are the green LEDs. So again, it's the same thing. So I'll come back when I've actually done both boards. Now I've got to do this again yet. Okay, all that's left to do now is to join these two halves together, and as I said, as long as the positives line up with each other, I believe it's this way. And I'll just double check before I commit to that. There should be a positive. There should be a positive there and a negative there. So yep, these are backwards. So I have to unjoin them if I can now. Okay, so I need to flip that 180 degrees. So yeah, so we got a positive there and a negative there. So the positive there and negative there. And it might be advisable to bend those transistors, or at least one of them, down a bit out of the way so it doesn't come into contact with it, which it will. And then trying to get these two to go down might be a bit challenging. One capacitor's coming into contact with another capacitor. So I need to move him out of the way. Okay, now it should come flush now. There we go. So now, as long as you get it right at this stage, you don't want to have to take it apart because it might be a bit problematic. So we now put the board in like that. We do have some leftover LEDs, I'm not sure why, they can't component count. So all I have to do now is, well, solder the two tree boards to the base board. So I'm going to get in there with the soldering iron and do that there. I'm assuming that there's a pad here and a pad here on the other board. I'm assuming that you join them together, so on both sides. So I might just confirm that by first plugging in some batteries and see what happens. If nothing happens, then I know I have to connect those. Alright, some batteries. Yeah, the double A. It's just difficult to put in. Okay. What a cheap piece of crap that is. Okay. Well, it's flashing. So one red LED is not working. Two red LEDs are hardly working. It's interesting though. I was trying to. So that's the flashing LED Christmas tree kit, but for some reason a couple of these LEDs aren't even doing anything. So I don't know if they're the wrong way around. Anyway, it's working, just not very well. Would have been nice if there was like a little white LED flashing on top here for a star or something, but there isn't. Anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, I'm the Astro 30 saying see ya and have a late Merry Christmas. Even though we're nearly February. Pretty soon it'll be Valentine's Day. And just as a finishing note before I close this video out, the two positive and negative marked up here is for another LED, a red one, that you mount on top as if it was a star. So you don't actually short these pins together, you just wire in another red LED. So I'm going to leave that run for a while and see how long it lasts before the batteries go flat. Anyway, that is definitely the end of this video. See ya!